All right, I guess that's my cue to start. That means I have to sing, right? Okay. All right, welcome to Exploring Containers and Orchestration in Azure. It's day 2, and I guess everybody's probably about tired of carrying their backpacks around for 2 days now, right? All right. My name's Shane Boyer. I'm a principal cloud advocate with Microsoft on the Azure platform. And today we're going to talk about doing some containers and the various ways that we can do them on Azure, or like I like to call it, how do I Docker on Azure? My handle there on Twitter is SP Boyer. It's pretty much how you can find me anywhere. I will be here throughout the week, so feel free to talk to me anytime. I was not lucky enough to grab one of those wonderful buttons. Hopefully my clicker works. All right, so before we get started, everything I'm going to talk about today is available on our resources hub. So if you have one of those wonderful little black computers we all carry around, take a picture of that, and all of the session code that I'm going to be doing will be available either immediately following or is already on the GitHub page that's there, and then all of the event session resources, not only from my session, but the other Ignite tour-related stuff and things that you're seeing this week will be available there. Session slides, video recordings when they're available, etc. So feel free to jump into that. Just real quick, kind of what I'm going to cover today is kind of why containers, why we should use them, what's the difference between containers and VMs, and then the various ways that we can do that on Azure. We have container instances, registries, why we might want to use those, why they're important, Azure App Service, and of course, Kubernetes, because that solves all of our problems. I need Kubernetes for my clicker. Okay, so what are containers? I think we're getting to the point where this is a part of our conversation constantly when we're talking about either developing new apps or moving our current apps into the cloud. So why are they important to us? And what I put on the slide here is kind of the standard definition. I'm not going to read it to you. But basically, containers offer a logical packaging mechanism in which our applications can be abstracted from the environment in which they actually run, prod, dev, test, etc. This decoupling allows container-based apps to be deployed easily and consistently regardless of the target environment. That being said, containerization provides a clean separation of concern, that isolation that we're always looking for, right? We're not having to worry about dependencies infecting or affecting our applications. And what this does is it allows our developers to focus on their applications and logic and dependencies, and our IT ops to focus on the deployment and management of our applications, and not really the software that might be affecting each other. So why would I want to use them? Works on my machine, right? We've never heard that before. So containers give the developers the ability to create predictable environments isolated from other applications. Every dependency needed by the application, versions of the runtimes, the libraries, etc., are all included in the container and are guaranteed to be consistent regardless of where the image is deployed. So I know that when I create a container for my app, it's going to run the same on my machine as it will on Brian's machine, or Susan's machine, or Jesse's machine. Prod, dev, etc. I know that it's always going to work exactly the same on all those machines. And what this does is it equals productivity. Developers and ops teams spend less cycles debugging or diagnosing environment issues and more time on pushing features and enhancements to the users. Also, they run anywhere. If you've seen many of the talks either before this event or at other events, we know that containers obviously run on Linux. That's where this whole story started. We now have Windows containers. Obviously, they run in the cloud. That's why we're all here. But they also run on drones, Raspberry Pi, and IoT devices. Containers, they ease the development and deployment of applications. Windows, Mac, Linux, data centers, cloud, and as I mentioned, even drones. There was a demo I saw where there was a drone actually doing its work, and through a CI/CD system, they were able to update the container running on the drone while it was flying, and it didn't crash. Literally didn't crash. So with the widespread popularity of the Docker image format, the containers helps with the portability. So wherever you want to run your software, you could probably run a container. So this is a common question that comes up. What's the difference between a container versus a virtual machine? I think a virtual machine is something we all pretty much understand. They've been around for a while. We're used to building them, asking for them, and waiting for them to be built for us. So within each virtual machine runs a unique guest operating system. VMs with different operating systems can run on the same physical server. You know, Unix VM can sit alongside a Linux VM and so on. Each VM has its own binaries, libraries, applications that it services, and the VM might be gigabytes in size, depending on what OS you're working with. The containers sit on top of a physical server and it hosts the OS. For example, like I mentioned, we can run a Linux or Windows. And each container shares the host OS kernel and usually the binaries and libraries too. The shared components are read-only, and the containers are pretty light. The node container right now is pretty small. We're talking in megabytes, like 16 megabytes. So that allows us to build and deploy these and scale these in just seconds, as opposed to minutes when it comes to VMs. In some cases, VMs take days for us to acquire and put them in our centers. Virtual machines and containers differ in several ways, but the primary difference is that containers provide a way for us to virtualize the application, where obviously the VMs are virtualizing the entire OS. So a real quick Dockerfile example here is, this one here is just a basic example of a Dockerfile. It uses the base image for a .NET Core 3.0 image. This one here uses the SDK for 3.0, which happens to be a Debian-based image, so Ubuntu. We're setting an environment variable for our application to development. We're creating a work directory of /app. The next line here, we're copying our source code, the first dot, to the /app, which is the second dot here. We're running a command, .NET restore, which in our case here would just restore all of the NuGet packages, all of our dependencies to build our app. And then our entry point would just run our application by running .NET run. In order for me to actually build this Docker container and create it for me to use it at other places, I would run a command, docker build, with a -t, which allows me to tag this image with my name of my repository, spboyer/ignite-AFUN60, which happens to be the name of this presentation. And that will build the actual Docker image. This essentially is a template for my application. The first line is the base image. This happens to be the Ubuntu OS that I'm using. It doesn't say that. I just happen to know that because it also is defined below the SDK base image. So if I went and dug into that base image, I would see somewhere down in that layer it uses Ubuntu. And now that I've built that, I can push it to a repository for me to use and deploy anywhere else. So for an example of how to kind of some more details on how that really works and some differences between VMs and containers, this is a first of many in the collection that we have for running containers on Azure. So if you look at that quick link there, there'll be some more links, and that one collection will hold all of our links that we'll talk about here. There's a lot of Learn references here that you'll want to check out throughout the course. So the first way that we can possibly run containers in Azure is Azure Container Instances. Azure Container Instances is a way to run containers in Azure with a single command. Okay, you can start a container using a single command, and this command can be run on a command line or Azure DevOps. I can use a logic app in order to fire up a container and do some work there. There's a lot of options to do that. It's per second billing, so what does that mean? I can fire up my Docker container. I've got an app. I run it. It does its job, and then it fires down, and I'm only billed for the time that that actual container is working. So just run the container. There's no infrastructure to manage, no virtual machine managed. I just do its work. So how would I get that done? I may have fibbed a little bit. I said it was just one line. It's two. We actually have to create a resource group. So this first line is create my resource group. I'm going to create it in East US here, and then I'm going to create my container here. So again, I've created my image, Ignite AFUN60. I'm going to say AZ container create. I'm using the Azure CLI to do that. And then I'm going to pass in my resource group. And then the last part of that command is IP address public. Now, in my case, this is just a simple web application that I'm going to run. So I want an IP address that's public so that I can obviously have the world view this application. The most important part about this is there's going to be some various output that comes out. And what I'm interested in is the IP address. So I asked for a public IP. So once the container is created, the output contains a lot of information, again, but the most important piece is just that IP. So in a few seconds, it would pull that image over into Azure Container Instances and create this particular image. So that's an example of what that would look like, and I can pull up that browser and view the page. So what are the use cases for ACI? Now, I used it for a web application. Now, obviously, there's a lot of ways to run a web app. ACI is probably not the best way to do it, but some of the other things that are good is data processing jobs. Have you ever had a server or a machine in your office, maybe you have one now, that its sole reason for existing is to run batch jobs, right? It sits under somebody's desk or in the server room, and all it does is process data and put log files somewhere, all right? Or it has a console app that runs on the Windows scheduler every Monday at 10 a.m. That's a great option to put that app in a Docker container, fire it up with a logic app into ACI, do its work, and fire it down. It's only going to be, you're only going to be charged a few cents, if even a whole cent, to actually run that job and do its work. It's a perfect way to do it. Reporting CI jobs, event-driven applications, again with the logic apps. And then another reason that we can possibly use this is virtual nodes, elasticity for your Kubernetes and AKS, and we'll get to that later. It provides a fast, isolated compute to handle spikes with your managing service. So through the use of the virtual kubelet, your AKS cluster is enabled and can scale with these ACI nodes. So that's another way we can do it. So some of the advanced features of Azure Container Instances is container groups. So we can group multiple of these ACI containers together if there's relationships between the two. A container group is useful when building apps for sidecar logging, monitoring, or other configuration where services need like second attached processes. By default, Azure Container Instances are stateless, so if the container crashes or stops, all the state is lost. So that's a situation where probably my web application is probably not a good use case scenario for me to use this. So to persist that state beyond the lifetime of the container, if you have some data stores that you want to work with, you want to mount some volumes, maybe in storage, and then mount those as you're running these other ACI instances. And it's really easy to deploy these from Azure Container Registry Portal as well. Now, some of the limitations that we have in ACI is clickers, zero downtime upgrades. So if you have a container that's running in ACI, you need to upgrade to a new version of whatever that container is running. It will actually go down before the new one comes up. There is no upgrade path for that. batch workflows, service discovery, load balancing, and auto scaling. If you need any of these types of features, you're going to need an orchestrator, and that's when you would move to AKS for those types of things. But for doing your batch work, if you have again, be able to process logs, download some files, do some work on them, and then move on, this is a perfect scenario. Those cron jobs, again, those jobs that run every Monday at 10 a.m., this is a perfect scenario for that. So there's a good learn module on ACI. Again, it's in that collection, so if you've taken a picture of that, then that's great. It'll show you how to run containers in ACI, control what happens in your container, et cetera, and you can run through that learn module, and some good course material there. Azure Container Registry, and there's a few mentions of that as we were going through ACI, is a way to store your images. So how does this help in building, shipping, and running an application? So why might an organization need a private registry to securely and efficiently manage their container images? And these are good questions. You can imagine a good analogy is kind of like GitHub, right? We need a place to store our code. We probably need a good place to store our images. The container is a snapshot of your application and its dependencies. And once that image is created, the registry is a place to hold that application template. A registry is a way to share that application between the systems. So once I've made that Docker image and I've put it in a registry, now that's a single place for me to deploy it. Docker Hub is probably the most well-known public registry, and it's available, it's easy to use, it's available via the internet, but you're also at the mercy of the internet when you're going to deploy your applications. So if that internet connection is down, I can't deploy my apps, I can't scale my applications if I can't get to that public registry. Also, with our code, there might be restrictions that prohibit us from storing our Docker images on public registries outside of our domain, country, et cetera. IP and sensitive data restrictions are all examples of that. The private registry allows for your organization to set up role-based access control to the registry based on LDAP, Active Directory, things like that's already set up within your organization. And it also allows for the efficient and secure storage through these mechanisms, right? So managing your private registry and private access to your images basically allows you to manage all types of containers, not just your Docker containers. It allows you to store Mesosphere, Docker Swarm, Kubernetes, and other Azure service types that are there, Helm charts as well. And you or your DevOps team can seamlessly integrate the build and deploy process, right into your workflows. Docker's command line interface works directly with ACR. All you have to do is log in. It's an Azure command on the CLI, as well as in the portal, we can do that too. It allows you to push, pull commands just like you would on Docker Hub, and there's really no new APIs to learn. The other option we have is Azure Containers geo-replication feature. So what this allows us to do is reduce the network latency between where your assets are actually deployed and where your registry is. So right now we're in the East US. I want to create an Azure Container Registry in the East US because I'm going to deploy my apps here. But if I also have a heavy customer usage, let's say in East Europe or West Europe, and I'm going to deploy there too, I have a way to push to one Azure Container Registry and have that geo-replicate multiple places as well. So that's really will reduce my deployment times when it comes to scaling my apps and deploying my applications. Super easy to create the container registry in the portal. It's point click, you look for Azure containers, it's right there in the portal. We also have the ability to create the basic registry. Here, this is a super basic. The cost optimize option for getting started is AZ ACR create, you pass your resource group and a name of your container registry, and we just ask for basic. Again, that's the single command to create that private registry. Super easy to log in. We have all of the standard commands. to actually pull your images, push your images there, and then also remove images as well. So there's nothing new that you're not familiar with if you're already using Docker with Docker Hub or with other types of registries. Now, I talked about the locale in reference to the other parts of Azure. It's positioned close to all of your other Azure objects. Your VMs, Kubernetes clusters, and AKS, App Service, and ACI, as we talked about earlier. So when you're pulling the image to your applications, these resources and the latency is greatly reduced. The benefit of this is scaling the CI/CD for your builds, deployments, and so forth. Using public repositories like Docker Hub or even GitHub, the ingress and egress costs are incurred because you're leaving Azure. So when you're pulling data from outside of Azure, there's costs incurred for you to do that. When you're pulling from ACR, there are no costs to do that because you're in the same data center in relation to your infrastructure. As you can imagine, we have a Learn Hub included, a Learn module included for ACR related to Azure Container Registry. It's included in that Learn collection. So the next service for deploying apps in containers is one of my favorite services is Azure App Service. Many companies can actually run on Azure App Service. It supports multiple languages and frameworks. It's an HTTP-based service for hosting all web applications, REST APIs, mobile backends. You can develop in your favorite languages. If it's .NET, .NET Core, Ruby, Java, Node.js, PHP, Python, etc. Your applications can run and scale with both Windows and Linux-based environments. You can deploy your apps from GitHub, Azure DevOps, and even Dropbox, if you believe that. App Service offers just about every piece you need to run scalable and secure web apps right there. We also offer within your slot deployments, you can kind of do blue-green deployments, scalability. That's also the basis. It's also the basis for our serverless apps too. So if you're running Azure Functions, which also supports containers, you can run. It all runs based on App Service that's there. And there's a lot of templates, IDE integration, again with serverless, if you're using Visual Studio, VS Code, all built in to deploy to App Service. So App Service is a fully managed compute platform that is optimized for hosting websites and web apps, and customers, you, can use App Service on Linux to host these web apps natively for the application stacks, as I mentioned, for Node, Java, PHP, etc. And it can all be run natively within the containers. So we have a couple of options when it comes to running the containers on App Service. You can just pull the images right from Docker Hub, or if you have your ACR set up, it's point and click to set that up, and the web app for your containers will deploy to the containerized app with your preferred dependencies with just in a few seconds. And we'll show that here in a second. You can actually simplify your container image deployments through CI/CD. So within your app service setup, we can actually set up a webhook. So every time you push your image, a new version of your container image, to your registry, we can auto deploy to the to your web app for containers instance and keep that updated automatically. You also have the option to scaling based on load, CPU, RAM, etc. And the load balancing is handled and can be overridden manually with the CLI or within the portal. So let me jump over to my other machine real quick. That needs to recognize my face. That is not the portal. So here's the application. I actually have this one running locally. And this is the container I built here. I've pushed it to Docker Hub as an option, but I also have tagged it and pushed it to Azure Container Registry. So if I go into the portal here, and I just did a new web app, is the first thing that I did here. And this is web apps for containers. I chose my subscription, my resource group, which I had already created. And the first thing I'm going to pick is a web app name. So I will just do AFUN60 Ignite. I should pick 2 just to make sure. It's going to check and make sure that we have not created that one before. Good, I got a green check. That's great. And I'm going to choose Docker container as the way that I'm going to deploy this. I could choose code, but obviously we're working with containers. And I'm going to choose Linux. I've chosen my region, East US. That's where all my customers are. And I have a Linux plan set up already for my pricing plan as a premium plan. The next thing I do is I'll hit next, and I'm going to choose how I'm going to deploy my app. Again, I have my option of, do I want to use Docker Hub or do I want to use Azure Container Registry? So it asks me what's my image source. So my image source that I'm going to choose is Docker Hub. And it's going to ask me what's my image and tag. So I'm going to go here. This is my image and tag. And we'll just copy that. Go back to web app. Put it there. Gives me a nice little check. I'm not going to monitor it right now. We'll just hit review and create. And let's see how fast we go. We're initialized, submitting deployment. It's in progress. Hopefully the internet likes us. And we'll see how fast this goes. All right. So we've got our AFUN60 web app that I created yesterday. And then what I can do here is if I go down to my container settings, this is one that I deployed yesterday, same image, gives me all of my logs. This is all the logs. It says it's extracting my image, pulling it, which is great. And then if I go back to my overview, it gives me my little URL here. We'll open this in a new tab. And it's ready to go right from my website. And that's super fast. And it actually looks like this one's done too. Oh, that one's still deploying. OK. So here we've deployed it from our app. Now, if I made a new push to my app, I can actually go down into the container settings. And we have this continuous deployment option. If I click this on, it would set up a webhook for me into my registry that if I put in a new tag, let's say I had a version of 1.0, if I push that tag to my registry, this would get a webhook saying there's a new version and would automatically push that container to my web app and update that for me. So anytime my Azure DevOps built my image, pushed it to the registry, it would push it to the website automatically, and I think that's pretty simple. And all I have to do as a developer is worry about building code and checking it in, and that's where I want to live. All right, let's go back to the code. 5. Okay. So, building containers on app service, part of that collection, check out the app service module that's there. And it runs through deploying those container apps to the application with Azure App Service, creating those Docker images, the container registry, et cetera, using the webhooks and talking through all those things there. All a part of that collection, and it's a really good learning track. So the final service, again, the service that solves everything is Kubernetes. Okay. So we have a fully managed Azure Kubernetes service, AKS, which makes deploying and managing the containerized applications pretty easy. It offers serverless Kubernetes, integrated continuous integration with the CI/CD experience, enterprise-grade security, governance, et cetera. And it is our single platform to rapidly build, deliver, and scale our apps with confidence. And it has elastic provisioning, our end-to-end development. There's a ton of tools that we're building on top of this. If you're in one of the keynotes this morning, you saw we've got Azure Dev Spaces that integrates with your tools in order to have that inner loop experience to build and debug, hit debug points, et cetera, that's there. So the elements of our orchestration: scheduling, affinity, health monitoring, failover, again, scaling, recovery, all of the things that you want when you're building and deploying your distributed applications in the cloud. You can easily provision the clusters using RCLI or obviously in the portal. So anything that we're showing that you can do on the command line also is available in the portal. So provisioning the clusters using the CLI or even code tools such as Terraform, ARM templates are available. You can minimize your infrastructure maintenance using the automated upgrade and repair and monitoring and scaling, and elastically provision additional compute capacity in Kubernetes in seconds without worrying about managing any of the infrastructure. Literally, it is a single command line in order to get new nodes, additional nodes. And you can work with how you want with AKS. Again, you don't have to learn any new APIs, any new command lines. We are actually using the built-in Kubernetes CLI tools in order to work with AKS. So how do we build, how do we create these clusters? Again, command lines, kind of where I like to live, but also available in the portal. Here we've got the Azure CLI, AKS create. We do need our resource group. We name our cluster, and we need to generate some SSH keys. And once that completes, we also have a command that will actually install the Kubernetes CLI into on your machine too, optionally, but also it will get the credentials and hook up your Kubernetes tool to the credentials on your cluster, allow you to work with that single command, so you're not having to worry about how to match that up. And then you can inspect your nodes and do all the commands that you like to do. So here we're doing kube control, get nodes, and I can see all the nodes that are ready and the various versions that are there. And then managing our AKS cluster is pretty simple as well. You can list and see the availability that's there, look at the releases, we can upgrade them to the latest versions. We also show that there's actually listing the versions, so we can actually upgrade to either the latest or even in preview versions available. And then scaling the cluster here, we can update our counts in this particular version to 10 if we need to really scale. And again, available in the portal. You can select create new from the left side, look at your containers Kubernetes service, and then alternatively, you can also use the search boxes available in the portal to create the new Kubernetes clusters as well. I mean, there's various selections of what type of networking. We do support Linux and Windows nodes now. I believe it's in preview. We'll have to check on that. We can run Windows and Linux nodes, so depending on what your workload needs are, you can deploy your applications to that. All right, let's see what Kubernetes looks like in Azure. Oh, wrong one. All right, so one of the apps that is available that we've built as a part of our Ignite tour is Tailwind Traders. This is my instance that I have running right now in my Kubernetes cluster. And it's a web application that's made up of various services. It's got a web front end that is built in combination of some JavaScript frameworks. The back end is built with Node and .NET Core and Java and serverless and all kinds of fun things. Some of that stuff I know how to build. Some of that stuff I have other parts of our team that builds, but we all work on it independently and it gets checked in and deployed. And this is a great little web app. It's available. It's all open source. And if I go in and look at my cluster that's here, I can look at my node pools. And I notice I've got 3 nodes. I've got a really large application running on 3 particular nodes. And I have the opportunity I could actually scale this application in the portal. But as I mentioned, I actually like to work in the command line. So we've got quite a bit of memory, quite a bit of cores in our capacity. We could actually just slide this the slider over and really super scale this out if I need be. Well, let's go and look at what type of things we're working with when it comes to the cluster. So I'm going to open up my Windows terminal. If you're not using Windows terminal, please go get it today. And I'm going to go ahead and look at, let's do a Q control get all. And you can see that here we've got, if I just look at just the services here, we've got a service that runs carts and coupons and image classifiers and login. We have a service that's just responsible for logins here. Products, et cetera. There's a profile service, et cetera. Another way to look at this here too is that I can actually, if I go and look at the Kubernetes dashboard, I'm waiting for that here to fire up. If it's going to behave for us. What this allows me to do, it gives me the Kubernetes kind of GUI based on what I'm looking at here, but I can also see this available in a web browser. Here we go. Should launch our web browser real quick here. And this is nothing new. We're not building anything new. This uses the same Kubernetes stuff that we're just syncing up with our AKS stuff. And you can see that we have our web applications. You can actually see the images that we're pulling. So that we're having to use Neil's version of the web application and services from his repo, and probably in a test mode right now. And if I actually wanted to see the actual YAML on how it's being pulled, what I can do is go out to our command line here. If I just do Q control, get pods. All right, we'll just pull this last one here. And what I'll do is look at the actual deployment file to see what kind of environment variables we were using. There we go. So I'm going to look for, you see all of our configurations that we're using, and if I'm just looking for the actual name, here we go. So here's that same environment variable that we were looking in our Docker file originally. And now I can see it's actually being used exactly the same inside of this deployment file here. If I scroll down some more, we've got some other configuration map keys that's being used by the application. And then also in this same deployment file, we'll probably see that we've got a liveliness path too, or we can set up to make sure that this thing is staying alive. You can see also that in our services here, we actually had one of our carts actually went down and we had an auto restart. It actually died, it killed. Something went wrong with it and actually had a restart on it as well. There's nothing that we had to do from an infrastructure standpoint that Kubernetes just solved. That went down and it decided it was going to restart that service. Something went awry and we brought it up and we can actually inspect the logs later on. Some of the other services that we could actually put on this is Azure Container Monitor as well to get some more in-depth look as to how this works. The point here is that I could use I use the same exact Docker container. I put it in ACI, I put it in app service, and then Neil actually has a version of my container that he was used to actually deploy onto the product pages in this service here. But it's the exact same code and the exact same container that we deployed everywhere. Now we just have it as a part of a big orchestration, but there was nothing different between how we deployed it. It's still a container, it's in ACR, and everything is happy when it comes to orchestrating it as a part of a bigger application. All right. So a part of our Microsoft Learn package there, we do have a full Kubernetes service there. It's quite a long course, that one there. Full walkthroughs on what is AKS and how does it work, some of the inner workings there. We do have the certification available too here, so be sure to check out the Learn modules that we've got available at the Learn booth. It is a free certification exam that you can take here, take it home with you and complete. So for the first time, Microsoft is offering the free cert exams to all the event attendees, so please take advantage of that if you get an opportunity to walk by. Also, all of the docs, if you look at AKMS, Azure Containers, AFUN60, there's a ton of docs and walkthroughs and tutorials and usable examples that are all related to some of the stuff that we talked about today. So be sure to check out there. And again, just one more time, this is probably the most important slide here. All of the resources, code for the repos, code for the examples that I had here is also available on GitHub, as well as the slides, etc. An upcoming session that I think is most important for you to check out if you're looking at doing some container work with some of your existing applications is modernizing your apps with containers. It's in the Chapin Theater on Friday if you're still in town. Check it out at 10:30. It's one of the other containerizing container sessions that I think is important when you're talking about moving your stuff to the cloud in containers. And we're talking about Windows workloads as well as Windows workloads too. And that's my time. I appreciate it. Thank you.